Problem 311 in the text deals with the propagation of uncertainty. The problem states, write each answer with the correct number of digits. Find the absolute uncertainty and the percent relative uncertainty for each answer. Part A of the problem is 6.2 plus or minus 0.2 minus 4.1 plus or minus 0.1. The answer will be the difference between 6.2 and 4.1 and a propagation of the uncertainty in each of those values. The problem can also be written without the parentheses. The values 0.2 and 0.1 represent absolute uncertainty. The percent relative uncertainty of each is calculated by the following equations, where 0.2, the absolute uncertainty, is divided by 6.2, the value, and multiplied by 100%. The product is 3.2%, or 3%. For the value on the right side, 0.1, the uncertainty, is divided by 4.1, the value, and multiplied by 100%, to give a product of 2.4%, or 2%. Uncertainty is always one significant figure. However, if we use the uncertainty for a calculation, we keep a second significant figure to prevent rounding errors. So if we are simply converting from absolute to relative uncertainty, we report 3% and 2%. But if we are using these values to do another calculation, we use 3.2% and 2.4%. When propagating the uncertainty of addition or subtraction, the absolute uncertainty is used in the following equation, where E3, the propagated uncertainty, is equal to the square root of the sum of each uncertainty squared. In this case, 0.2 is E1 and 0.1 is E2. When those numbers are squared, we have 0.04 plus 0.01, the sum of which is 0.05. The square root is 0.22. Next, we calculate the difference between the original values. 6.2 minus 4.1 is equal to 2.1. Then we combine this difference with the propagated uncertainty. So 6.2 plus or minus 0.2 minus 4.1 plus or minus 0.1 is equal to 2.1 plus or minus 0.2. Recall the propagated uncertainty was 0.22, but the uncertainty rounded to one significant figure is 0.2. Uncertainty is only reported with one significant figure. Finally, the relative uncertainty is 0.22 divided by 2.1 times 100%, which is equal to 10.47%, and rounds to 10%. Is 9.43 plus or minus 0.05 times 0.016 plus or minus 0.001. The percent relative uncertainty propagated is equal to the sum of each of the relative uncertainties squared. In our example, 0.05 divided by 9.43 times 100% is equal to 0.53%. This is the percent relative uncertainty of 9.43 plus or minus 0.05. The percent relative uncertainty of 0.016 plus or minus 0.001 is 6.3%. When we plug these values into the uncertainty propagation equation, we find that the percent relative uncertainty, E3, is equal to 6.2%. We then convert percent relative uncertainty of E3 into absolute uncertainty E3. To do this, we divide 6.2% by 100%. We always divide by 100%. We then multiply by the value, which is 0.15088. This is the product of 9.43 times 0.016. Therefore, E3 is equal to 0.0094 and rounds to 0.009. The product of 9.43 times 0.016 is 0.15088 in the calculator. However, we need to reduce the number of significant figures so that the uncertainty has only one significant figure, 0.009. The significant digit, the 9, is in the thousandths place. Therefore, we round the product 0.15088 also to the thousandths place at 0.151. Therefore, the product written correctly and with the propagated uncertainty is 0.151 plus or minus 0.009. Note that both values are rounded to the thousandths place. One incorrect form of the product is as follows because the product is not rounded to match the uncertainty. This would be 0.15088 plus or minus 0.009. This is incorrect. Another incorrect form, because the uncertainty is not rounded to one significant figure, is 0.1509 plus or minus 0.0094. The value is rounded to match the uncertainty, but the uncertainty should be rounded to only one significant figure, so this is also incorrect. Part C of problem 311 has mixed operations. First, there is a subtraction done within the parentheses, and then the difference is divided by another number. When working with more than two numbers, order of operations is critical. In this problem, the calculation within the parenthesis is performed first, although it is the calculation already completed in problem 311a. The answer is 2.1 plus or minus 0. However, to prevent rounding errors, we need to keep an extra digit in the uncertainty and write the remainder of the problem as 2.10 plus or minus 0.22 divided by 9.43 plus or minus 0.05. The left side is incorrectly written, but it is a necessity to prevent rounding errors in the next calculation step. So the problem is now 2.10 plus or minus 0.22 divided by 9.43 plus or minus 0.05. We again use the propagation of uncertainty using percent relative uncertainties as we did in part B. And then we find the percent relative uncertainties. For the number on the left, 0.22, the uncertainty is divided by 2.10, the value, and multiplied by 100%. The product is 10%. For the number on the right, the uncertainty 0.05 is divided by 9.43 and multiplied by 100%, and the product is 0.53%. These numbers are then inserted into the equation above. The sum of 10 squared plus 0.53 squared is 100, the square root of which is 10. Therefore, the percent relative uncertainty is 10%. We then convert this to absolute uncertainty by dividing the 10%, our percent E3, by 100. Again, we always divide by 100%. And we multiply it by the quotient of 2.10 divided by 9.43, which is 0.22269. This rounds to 0.022, the number we would use for future calculations, and then rounds all the way to 0.02. Thus, problem 311C is 0.22 plus or minus 0.2. And the relative uncertainty is 10%. Part D of problem 311 deals with mixed operations as well as scientific notation. This problem has a new feature, scientific notation. When propagating uncertainty in addition and subtraction, the scientific notations must be in the same power. When propagating uncertainty in multiplication and division, the scientific notations can be different since we are working with relative uncertainty. Note that the way 6.2 plus or minus 0.2 times 10 to the minus 3 is written indicates that both 6.2 and 0.2 are to the power 10 to the negative 3. So it could alternatively be written as 6.2 times 10 to the minus 3 plus or minus 0.2 times 10 to the minus 3, or 0.0062 plus or minus 0.0002. The number on the right is the least sloppy and is preferred even to how it is written in the problem. However, we will proceed as written in the problem for sake of demonstration. Step 1 is to check that the scientific notations in the addition are in the same power. They are both 10 to the negative 3. Step 2 is to perform the calculation inside the parentheses. Step 3 is to perform the multiplication. Since we have already checked off step 1, we will proceed to step 2, which is to perform the calculation inside the parentheses. To do so, we will propagate the uncertainty by squaring 0.002, which is E1, plus 0.001, which is E2. The sum of these squares is shown as 0.00000005. The square root of that number is 0.00022, or 2.2 times 10 to the negative 4. So the addition inside the parentheses is 10.3 plus or minus 0.2 times 10 to the negative 3, or 0.0103 plus or minus 0.0002. However, we will keep an extra digit only to prevent rounding errors while we move to step 3. Therefore, step 3 will be to calculate the product 9.43 plus or minus 0.05 and 10.30 plus or minus 0.22 times 10 to the negative 3. We can rewrite the problem, as shown here, with the extra parentheses added to show that the 10.30 plus or minus 0.22 is all that is multiplied by 10 to the negative 3. The 9.43 plus or minus 0.05 is not to the power 10 to the negative 3. When we perform propagation of uncertainty with multiplication, we use the percent relative uncertainty. So 0.05, the uncertainty, divided by 9.43, the value, multiplied by 100%, is equal to 0.53%, the percent relative uncertainty. The number inside the parentheses then has a percent relative uncertainty of 2.1. When these are inserted into the uncertainty propagation equation, we find that the percent relative uncertainty E3 is equal to 2.2%. We then divide 2.2% by 100% and multiply by the product, which will be 97.129 times 10 to the negative 3. Therefore, E3, our propagated absolute uncertainty, rounds to 2 times 10 to the negative 3. Therefore, the answer to problem 311D is 0.097 plus or minus 0.002. And the relative uncertainty is 2%.